Welcome to another edition of Math for No Reason. In this edition, we are going to prove this inequality, which is referred to as the Wirtinger's inequality. So let f be a function whose domain is the closed interval 0 to pi and it takes real values. We assume that this function is continuously differentiable and satisfies the fact f0 is equal to f pi is equal to 0. Then integral 0 to pi f prime t square dt, where f prime t is the derivative of f, must be greater than equal to integral 0 to pi f square t dt, and the equality will hold if and only if ft is some constant times sin t. You can easily check that sin t is a continuously differentiable function and this ft would be 0 at both t equal to 0 and t equal to pi. So the equality will hold only for a multiple of the sine. So let's see how we can prove this. Now to prove this, we will introduce a new function g, which will be ft by sin t, or in other words, so ft would be gt times sin t. Now, if we differentiate this function, so that derivative of f would be by the product rule g prime t sin t plus gt into cos t. So that's a straightforward application of the product rule. Now we will look at f prime t squared. So f prime t squared would be g prime t squared into sin squared t plus g squared t into cos squared t plus twice gt into g prime t into sin t cos t. And this is the function that we will integrate between 0 to pi. Now the integral will break up linearly, so this would become integral 0 to pi g prime t square sin square t dt plus integral 0 to pi g square t cos square t dt plus integral 0 to pi 2 gt into g prime t into sin t into cos t. Now first we will be examining this term, twice gt into g prime t into sin t cos t dt. Now if you look at that term, and we will use the integration by parts on this. So we will take the first function u to be sin t cos t and dv to be 2 gt into g prime t. Then your v would be g square t and du would be minus sin square t plus cos square t. Now these are all easy to check, and therefore we can now apply the integration by parts formula and get, now since sine is 0 at both 0 and pi, so we get the first term to be equal to 0, and taking this minus inside, what we get is integral 0 to pi g square t sin square t minus cos square t. So the first term is 0 and this becomes just this integral. Now let us put everything back and see what we get. So integral 0 to pi f prime t square dt is equal to integral 0 to pi g prime t square sin square t dt plus integral 0 to pi g square t cos square t dt plus integral 0 to pi g square t into sine square t minus cos square t. So on simplification, we see that g square t cos square t terms cancel, and what we are left with is integral 0 to pi g prime t square plus g square t into sine square t. Now g square t sine square t, g square t sine square t, this term is nothing but f square t. So remember that our ft is gt into sine t. So f square t is g square t into sine square. So this thing becomes integral 0 to pi g prime t square sine square t dt plus integral 0 to pi f square t. So we have, so this quantity here is an integral of a non-negative quantity, and therefore this is always greater than equal to 0, and therefore we can conclude integral 0 to pi f prime t square dt is greater than equal to integral 0 to pi f square t. So this proves the Wirtinger's inequality. Now when does equality hold? Now equality will hold only if this term is 0. And when is this term 0? So this term is 0 only when g prime t is 0. So integral 0 to pi g prime t square sine square t dt is equal to 0 only when g prime t is equal to 0. Now, if the derivative of a function is 0, we know that that would mean that gt is a constant, say, let's call it a. So, since gt is a constant a, so ft, which is gt into sine t, is nothing but a into sine t. So, in the Wirtinger's inequality, equality holds only when ft is equal to a times sine t, where a is a constant. This proves the above result. Thank you.